See a little spider web in the corner, but no fire ants. Now, I've got a lot of power there. At least enough power that if there were fire ants there, I almost certainly would have seen it. Now you can be confident that that null hypothesis is correct. Unless they were hiding in the cracks or something. There's always that chance. So, when we cover power, I'm going to show you how you can design your research such that you have so much power that even if the effect was very small, as long as there was an effect, the null wasn't true, you'd be almost certain to find it. And if you do your research that way, do a power analysis beforehand, and then do the analysis the way the power analysis suggests. The power analysis is going to tell you how many subjects do you need to get this much power. Then, if you can't find something, you can say, hey, it's not there. Now that's a little overly optimistic because when you do this, usually you find out you need lots and lots of subjects. So for example, let's say here we found out to have the amount of power we wanted. We need to have 200 subjects. And then we find out how much it costs to give an IQ test, an individually administered IQ test, a few $100s a piece. We say, hey, I can't afford that much. But sometimes data are cheap, and we can get the power we need. The next exercise is a correlated t-test. Let's take a look at the correlated t-test data. And these data are the data that we entered the first day we went down to the lab. We had data, this was data out of the Minitab handbook. We had data on pulse rate before exercise, pulse rate after exercise, whether the individual was a smoker or not, and then we computed difference scores, how much pulse rate changed. I'm going to start out here by giving you some of the information from that initial analysis. Remember how confused you were with Minitab that first day? It's not quite as bad now, unless you're dealing with the folks in Austin. Really, they know there's a problem and they're working on it. Part of the problem is this. In fact, this may be the entire problem. It's student helpers that are working there, especially in the evening when you guys are in there. You know, the regular staff are home. Student helpers typically are learning how to do the job, and they're typically getting paid just a little bit more than student wage. Once they learn how to use computers, they're likely to learn. They can get paid 2, 3, 4 times as much if they go to work for Kinko's or some other firm in Greenville than they will be working here on campus. So as soon as they get trained up, they're out of here, and then we have a new crop of student workers. Now, you know, in part, that's the university achieving its mission. You know, we're training the students to do something and get them a good job. That's only part of the university's mission, but that's an important part of the mission. You know, we're training you to be critical thinkers, too. But it causes problems. Because once they know how to do the job, they leave us. In fact, oftentimes, the students, once we get them well trained, especially in things like computing and statistics and research skills, they'll write us or phone us a few years later and say how happy they are using the skills they learned at ECU, and they may mention something about what their starting salary was, and usually the professors will cringe a little bit then because it's very often more than we pay. So, well, sometimes we lose our graduate students that way before they even get their degree. They go out on a summer internship before their thesis is done. They've been living as a graduate student for a while, and that's really a life of poverty. You don't have much money. You all know about a life of poverty. It continues through graduate school. They go out on a summer internship and start making some real money and get offered a job, and they just kind of say, well, I'll do the thesis next year. And then next year comes and they say,